Okay, here is Lesson 12, Antiderivatives. So the first thing I want to do is I want us to take the derivative of these three functions and see what they have in common. So what is the derivative of x cubed? So the derivative of x cubed is 3x squared. So what is the derivative of x cubed plus 7? So the derivative of x cubed plus 7 is 3x squared. What is the derivative of x cubed minus 9? So the derivative of x cubed minus 9 is 3x squared. So what do these three functions have in common? They all have same derivative. We call this a family. So this is called a family of derivatives. Okay? So now what we're going to be doing is we're going to be going the other direction. So what I'm going to do is I'm going to give you the derivative. So this is the derivative. And you're going to tell me the original function. Okay? And the reason you put the plus c is to denote the family. Because this is the original function, so this includes the entire family. This is to include the entire family. Okay? So, now, there are what we call certain integration formulas. So, let's think about this. So, if you take the derivative by pulling down the exponent and subtracting 1, how are you going to go the other way? You're going to add 1 to the exponent and divide by the new exponent. Okay? This is called the power rule. Okay? So I want to do a couple of little integrations here. So what if I give you the integral of a constant, so say c, x to the 0, dx. Now, this integral sign right here and the dx go hand in hand. They are both operators. You can't have one without the other. All right? So by the power rule, we say c x to the 0 plus 1 over 0 plus 1 equals c x to the 1 over 1. Oh, sorry, we got to have our plus capital C equals cx plus capital C. So if I integrate a constant, and they used k, then I get kx plus capital C. All right? Does everybody see that? And I just used a C because we always use C's for constants. All right? So now the other one is if I integrate just and that's just integrating a number. And they say if I integrate 0, I get a constant. So I always have plus c. So what happens if I integrate just x to the first dx? Well, then that is x to the 1 plus 1 over 1 plus 1 plus c, which is x squared over 2 plus c. Is everybody getting the idea? Now, any kind of number like this, what I like to call it is a tag along. So it's like a little puppy that follows you around and goes everywhere with you. Okay? So it's going to be 4 times x to the 7 plus 1 over 7 plus 1 plus my capital C. So that's 4x to the 8 over 8 plus c. So that's x to the 8th over 2 plus c. Now let me say this. If you can go from here to here or from here to here, then go forth and do it. Okay? And if you forget the plus c, minus 1. Minus 1 for no plus c. Oops, cancel. I hit the wrong place. Okay? Now, let's go here. So this is the integral of negative 6x to the 0 dx. So that's negative 6x to the first over 1 plus c. So that's negative 6x plus c. Okay? So, add 1. So that's x. What is negative 3 plus 1? That's negative 2. So this should be negative 2 over negative 2 plus c. We're done. This is the integral of 11x to the 1/3 dx. If you do not write the dx, so no dx, then minus 1. Minus 1, no dx. All right, so 1/3 plus 1 is 1/3 plus 3 over 3, so that's 4/3. So this equals 11 plus, not plus, 11x to the 4/3 over 4/3 plus c. Guess what? You have to simplify this. So what is 11 over 4/3? Well, that's 11 over 1 times 3 over 4. So that's 33/4. So this is 33/4 x to the 4/3 plus c. Okay? To integrate this, we have to rewrite it. The integral 4x to the negative 2 minus x to the negative 3 dx equals 4x to the negative 1 over negative 1 minus x to the negative 2 over negative 2 plus c. So that equals minus 4 minus 4 over x plus 1 over 2x squared plus c. Because it started out in the denominator, I have to end in the denominator. Okay? There's a look at number 5 again. So this is the integral of 3.3 plus 5t to the negative 0.9 plus 1/3 t to the 1.2 dt. So that equals 3.3t plus 5t. What is negative 0.9 plus 1? Well, that's 0.1, right? To the 0.1 over 0.1 plus 1/3 t to the 2.2 over 2.2 plus c. So that equals 3.3 t. Now this is 1/10 plus 50 t to the 0.1 plus 2.2 times 3 is 6.6. So that's t to the 2.2 over 6.6 plus c. Okay? This equals the integral of 3 I changed this to a square. So 3 so this should be a squared. So this is 3 minus 7x to the negative 2 dx. So from here to here, I have 3x squared over x squared minus 7 over x squared. So this equals 3x minus 7x to the negative 1 plus c. So that equals 3x minus 7 over x plus c. Okay, now let's do the word problem for lesson 12. So your name is Galileo. You toss a weight upward 8 feet per second from the top of the Leaning Tower of Pisa. So that's 185 feet tall. Okay, neglecting air resistance, find the weight's velocity as a function of time. If we know that acceleration, hello, that's the wrong one. If we know that acceleration due to gravity is 32 feet per second squared, then we know that the velocity is 8 minus 32 t. All right. So then, to find the height, we integrate that function. All right? Because the derivative of distance is velocity. So then the integral of velocity is distance. So S of t equals the integral of v of t dt, which equals the integral of 8 minus 32 t dt. So that's 8t minus 32 t squared over 2 plus c. All right. All right, so that means that S of t equals 8 8t minus 16t squared plus c. Now, we know that at time equal to 0, we have that the height, or that s of 0, we get 185. So that tells us that if we put 0 in here, that this will be 0, and this will be 0. So that tells us that we have s of 0 equals 185. So that equals c. So this tells us that s of t equals minus 16t squared plus 8t plus 185. All right? So now we know that the peak is when the velocity equals 0. So when is 8 minus 32t equal to 0? So that's when 8 equals 32t. So t equals 1/4. So that's at 1/4 of a second. So that tells us 1/4 of a second is when we're at our highest point. So now, what is s of 1/4? So that's negative 16 times 1/4 squared plus 8 times 1/4 plus 185, which equals 186. So the weight will reach its zenith or peak at 1/4 a second and 186 feet. Okay, now I want to make a note here. So note, in the video, I used s of t, but in the notes, I used d of t. It doesn't